Hi everyone, my name is MacLane Wilkinson. I am one of the co-founders of a company called NuCypher. We work on a technology called proxy Reencryption that we've implemented for several different distributed systems. I'm going to focus on what we've implemented for blockchain and decentralized applications today, but we've also previously implemented proxy Reencryption for other distributed systems, specifically like Github, Kafka, and some IoT stuff. But today I'll be talking about our decentralized key management system. So basically the problem that we're solving is we are a data privacy layer for blockchain and decentralized applications. So we give developers a way to store, share, and manage private data on public blockchains, or more specifically public file systems like IPFS and Swarm that sit on top of these public blockchains. So for example, if you're building a medical records application, let's say on top of Ethereum, and you want to store patient records on IPFS, we give you a way to have those records be private, confidential, and encrypted, but at the same time have those encrypted records still be shareable with a valid recipient. So let's say a doctor or a hospital. And we're this access control infrastructure for anyone that's building a decentralized application. So some of the very sort of low-hanging fruit use cases is obviously like encrypted, end-to-end encrypted decentralized file sharing. So you could imagine using NuCypher as a primitive to build like a decentralized Dropbox, for example, where you need to encrypt and share, let's say, photos with your friends and family, or this medical records use case, records with your healthcare provider. It's also a very good primitive for building end-to-end encrypted group chats. And this actually isn't just a challenging problem in the decentralized context, but also a centralized context. Namely because encrypting each message between each participant in a large group chat is a very computationally expensive operation. Which is why if you look at like Telegram group chats, by default those are all plain text. Whereas you can use proxy Reencryption to easily add and revoke read and write access to an encrypted channel. You can also use proxy Reencryption to build or construct data exchanges or data marketplaces where you have some encrypted content. Let's say it's genomics data or video streams, and you only want to give people access to that encrypted content in exchange for payments. So you can combine proxy Reencryption with a smart contract to say only allow decryption in the event that the recipient pays, let's say, 5 to the data owner's address. We kind of compare proxy Reencryption, or what we're doing for DApps, to HTTPS, but for a decentralized application. So obviously the way we solve the data integrity and data confidentiality problems in a centralized context is with things like TLS and encryption in transit and flight. But fundamentally, when you're using these centralized service providers like Dropbox or Box or Google, all the data is getting decrypted server-side. And while it's probably fine to trust Google or Dropbox with your data, it doesn't make any sense at all if we extend this to a decentralized context where you could be storing data on an IPFS node that's sitting in Russia or some random person's basement. You obviously want to have, you don't want to be just sort of throwing your data out there, particularly if it's sensitive. And so what we've done at NuCypher is we've combined two core technologies to create a way to manage private data, effectively create a decentralized key management service. The two technologies that we use are proxy Reencryption, and then obviously decentralization using the Ethereum blockchain. And to build up to that, I'll talk a little bit about what proxy Reencryption is and how that works. But proxy Reencryption is fundamentally just a more scalable form of traditional public key encryption. So if you think of traditional public key encryption as being very good for one-to-one communication, let's say I have some secret message that I want to share with one of you in the audience, I can encrypt that message with your public key, send it across the network. You can decrypt with your private key. It works very well. But let's say I need to share that message with not just one of you, but everyone in this room, everyone in this conference, everyone on this block, a couple hundred or 1,000 people. That starts to get very expensive. I have to encrypt the message for each recipient, send it across the network every time. It just starts to scale very poorly. And with proxy Reencryption, what I can do instead is I can encrypt that data and that message one time under my own key. I can store that data, in S3 or IPFS or Swarm, and then I can delegate and revoke access to the data to arbitrarily as many recipients as I want, using something called a Reencryption key. And basically what proxy Reencryption allows me to do is to re-encrypt or rekey or transform the data that's encrypted for me into being encrypted for some recipients. And that can happen without ever exposing the plaintext data to the storage layer, so it's a direct ciphertext to ciphertext transformation. And you can imagine using proxy encryption to build a centralized key management service. In this case, we have some data owner who has some, bulk data that they want to encrypt and store on a storage layer. So what they'll do is they'll encrypt the bulk of the data with a symmetric key. They'll encrypt that symmetric key with their public key, attach that encrypted symmetric key to the data, the encrypted data, and store it in IPFS or any storage layer. If they want to delegate access to that data to some recipient, what they can do is they can take that recipient's public key, use that public key along with their own private key to create something called a Reencryption key. And that's a one-way function. So once you use the two inputs, the data owner's private key and the recipient's public key to create the Reencryption key, there's no way to reverse that. And they'll give that Reencryption key to some untrusted proxy. And the only thing the proxy can do with that data is to basically re-encrypt the encrypted symmetric key so that it is now encrypted for the recipient, and the recipient can use their own private key to decrypt it and use that to decrypt the bulk of the data. We've actually taken that a step further and created a split key threshold version of proxy re-encryption we call Umbral. And basically it's tunable, so you can set some threshold, say 30 or 50, take a one re-encryption key, split it up into a bunch of shares, and set some threshold number of those shares that are required in order to re-encrypt. Say 30 or 50, 10 or 20, whatever you like, it's tunable. We issue those shares out to a network of proxies or nodes, and then in order to re-encrypt, some quorum or threshold number of those nodes with the requisite number of key shares need to come together and agree to re-encrypt. So this basically splits the trust across many nodes as opposed to one. And if you're using NuCypher's KMS, now you don't need to trust a centralized service provider like AWS Cloud HSM or HashiCorp Vault, or even us as NuCypher. Just a few details on the threshold algorithm that we've created. We call it Umbral. Basically, it's a key encapsulation scheme, so you don't actually re-encrypt the bulk of the data, although you can, but for performance reasons, generally you'll encrypt the bulk of the data with a symmetric key, and then you'll do the re-encryption on that encrypted symmetric key. We also have a way to verify the correctness of re-encryption cryptographically, which is kind of interesting. We have a lot more documentation on our GitHub org at the Umbral doc repo, and then we have reference implementation that we've done in Python, which is also available. So we also tokenized this protocol, and the reason we do this is we need some way to distribute work to the nodes in the network, as well as to incentivize people to run nodes. So that's done with our token. If you want to be a node in the NuCypher network, you have to stake the token as a form of collateral for a security deposit. And we do that. We do a couple things with that. One, we use it to allocate work. So you'll get re-encryption keys, and you'll provide re-encryption services for the network in proportion to the amount of stake that you put up. And we also use it as a way to ensure that nodes are behaving correctly. So if you have a malicious node or a node that goes offline and isn't doing its job, that node's stake will get slashed. A few examples of the types of use cases that we're seeing are, a big one is this medical records data sharing use case that I talked about before. So there's a lot of projects that are using us to create patient-controlled medical records platforms, so like MediBlock or Irio or Medicine in Europe. We also enable this idea of decentralized data exchanges or data marketplaces. So there are a lot of projects like Datum or Ocean Protocol that are aggregating a bunch of different kinds of data. It could be user browsing history, social media data, genomics data. They're encrypting that data and then monetizing it by auctioning it off to advertisers or researchers, conditionally decrypting in exchange for payment. We've also seen a lot of databases start to use us as the access control layer. So being able to control who can and can't query some of the decentralized databases like BlueZell. All of our development on this happens in public on our GitHub and Discord. If you're interested in learning more, we have a very detailed technical white paper, which is also available on our GitHub or on our website. Again, that reference implementation of Umbral is on GitHub in Python. And my email is just MacLane@NuCypher.com. Thanks very much.
Thank you. going to take the first question.
Cool.
You mentioned Ethereum a few times. How blockchain specific are these software?
Sure. Our particular network is built on top of Ethereum, but sort of a meta protocol. So if you're building a DApp on another platform, you can still use NuCypher. You just have to have some way to do cross-chain payments, which sort of doesn't exist that well today, but I think it's kind of expected to be around soon. Also, for whatever reason, there's nothing specific about Ethereum that makes NuCypher work other than having smart contracts. So for whatever reason we needed to move to another platform in the future, we could just save the states and move it that way.
My question is about data exchange platform that you mentioned.
Yep.
Let's say I'm a content creator. If I create my content on a blockchain by itself, let's say I'm using Steemit or BAT or those kind of platform to, Raid, to create my content. It's already on blockchain, so it's already immutable, and I can monetize that. So what you add here is more security on the top of that, or
We basically
immutability.
So we add a way to control who can and can't access that data. So if it's public data, it's a blog post on Steemit or something like that, then you probably don't care if everyone in the world sees it. But if you want to gate access to that data, let's say it's like medical record or something, and you want to control who can and can't access that data, you only want to allow, say, your healthcare provider or it's some piece of content that you want to monetize by selling access to it. You could use us as a way to control, additionally decrypt, allow others to additionally decrypt data in exchange for payment.
Okay, and if other companies wants to bid on those data exchange platform, they need permission. So you can give some people permission to bid on different type of data.
Yeah, so you could combine this with, let's say, a smart contract that says only allow access to this piece of encrypted data to whoever the highest bidder is, or only allow access if they've paid access to this encrypted video stream if they paid like some subscription fee to your address, for example.
Great, thank you.
Thanks.
So I'll ask another question. What kind of, how general are these methods you've implemented? So for example, what you're describing earlier with having multi-party secure communications, it sounds like, was reminding me of things like it's Samir's secret sharing scheme and that kind of stuff. Is this a really general idea here, or is it specific to that use case?
Sure, so this is like a very similar approach. This ability to split the re-encryption key is very similar to Samir's secret sharing, which is just splitting a private key. So it's the same concept. You're splitting up this this key. The difference here is we're splitting up the re-encryption key versus splitting up a private key. So it's actually, in this case, it's slightly more secure because if someone is able to maliciously get a hold of a sufficient number of shares to reassemble the key, in the case of Samir's secret sharing, they reassemble the private key, which gives them access to the data. In this case, they just reassembled the re-encryption key, which only allows them to re-encrypt the data. So they'd also have to do that, plus compromise whatever private key that re-encryption key is re-encrypting or targeting.